Good morning, students. Myself, Dr. BADI ALEKHYA, Assistant Professor, Department of Artificial Intelligence and Machine Learning, R.M.D. Engineering College. Today, we are going to discuss the concept meta algorithm. In the name itself, meta is there. That means implementing the model more than one algorithm. So here it is a powerful tool for improving the performance of deep learning model. Mainly we are automating the process of finding optimal hyperparameters, architectures and learning algorithms by using these meta algorithms. In the previous sessions we discussed that what are the optimal hyperparameters, what type of optimal hyperparameters is suitable for which type of architectures and learning algorithms will be decided by using these meta algorithms. So hyperparameter optimization, or in the previous class we discussed that what is the need of hyperparameters. It's only decided that what are the best optimal parameters will be needed to improve the performance of the model. So same thing, grid search, random search, bias optimization, gradient based optimizations. That means when we are concentrated on these hyperparameters only, which type of optim, that means in the previous session we discussed that hyperparameters for convolutional neural networks is how many number of filters we are considering, what is the stride size, what is how, which type of pooling technique we are following, or when in the case of recurrent neural networks, what is the step size, what is the learn rate we are considering when you are doing your test classification. These are the some of the hyperparameters needed in the optimization of the model in the given neural network. And what is the neural architecture search means? For generating, we initially tell that for three reasons we are considering meta algorithms. One is for hyperparameters, and second is for neural architecture search. Which type of architectures? Among the pool of candidate architectures, what is the evolutionary algorithms? What type of architectures we have to consider and trying to validate the data sets to assess its performance will be, and also it will be helpful to select the best architecture, uh, and then it is using the performance of that architectures to train the final model. So the second benefit of meta algorithm, it will be helpful to decide which type of architecture will providing a better performance to train the network in a efficient manner. And meta learning, how we are going to learn the networks. So ability, the we can make the network meta in meta algorithms like reinforcement learning, when initially like policy reward technique, it will improve the ability of a model by learning new tasks quickly and efficiently. And also few short learning, we have trained the models to a limited number of examples, enabling adoption to new situations. And transfer learning leverages knowledge gained from one task to improve the performance on the another related task. Why meta learning comes to takes place in this manner means, when meta learning, when we are giving any new task to the model, the model can able to learn that new task, and with a few example itself it has to adapt to the new situations, and also gained knowledge from for implementing of output from one task to the another related task. These are the some of the advantages and the some of the things needed to implement meta learning. So you observe that when we are doing our lab experiments, we are using transfer learning because we are going to train the model with one algorithm. By applying the transfer learning, we can improve the performance of the model when it is doing completing one task. When compared to the executing the another task, it will be improving the performance. So, what is reinforcement learning for meta algorithms? Like exploration and exploitation, after completing any actions, we have to reward. After receiving the reward, it again has to has a main role to improve its optimization by maximizing this award. And value function also we are using, and makes the machines to react with the different states and performing the actions based on the expected hours. This is the techniques or reinforcement learning of meta algorithms. And we are considering an ensemble models methods for meta algorithms by bagging, boosting, and stacking. Already you are aware of what is bagging, boosting, and stacking. We are training multiple models on different subset of data and combining their predictions. And under boosting, instead of focusing on these things, we are sequentially training and focus on correcting the errors made by the previous models. For example, if one model is doing the mistake, means I have to train the model in the next sequence by correcting that errors. And stacking, combining the features of both bagging and boosting, we are improving the overall performance. So, what are the interpretability and explainability in meta algorithms means it identified which features are most influencing the model predictions, and also visualizing the decision making process of the model, how it is arriving to the specific outcome, and also when the input features are changes, how when the input of features are changes in the given model, and how it is going to affect the model performance, and also sensitivity analysis by impact of changes in the hyperparameters values. For example, if I am changing the number of filters, number of states, number of which type of pooling technique I am used under that convolutional neural networks may be affecting the, and also it is going to assess that how that hyperparameter values will affect the performance of the models. These are the some of the advantages of using meta algorithm in your deep learning model. Thank you, students. That's all for the today's session. I will meet with some other new concept in the next session. Thank you all.